The OSI model. The Open Systems Interconnection model characterizes and standardizes communication through a 7-layer process. Layer 7 is the application layer. This layer provides interfaces for applications to access network services, handles error recovery for applications. The PDU at this layer is referred to as data. Components at this layer have both a client and a server component. Computers that have network OSs and some security devices operate at this layer since they work with the application layer protocols. Some problems with this layer include missing or misconfigured client or server software and incompatible or obsolete commands used for communication between a client and a server.
Layer 6, the presentation layer, handles data formatting and translation, converts data to formats specified by application layer, which is outgoing messages, reverses conversation if required by the receiving application, which is the incoming messages, presents data to the application layer in suitable format. Some of the tasks it performs are protocol conversion, data encryption and decryption, data compression and decompression, data representation, and compatibilities between OSs and graphics commands. Layer 5, the session layer. The primary job of the session layer protocol is to provide the means necessary to set up, manage, and end sessions. Allows two computers to hold ongoing communications called the session across the network. Applications on either end of the session can exchange data as long as the session lasts. Manages the mechanics of ongoing communication, such as identifying which side can transmit data and for how long. A process called checkpointing is also performed at this layer. Checkpointing is the synchronization process between audio and a video stream in a web conferencing application.
Layer 4, transport layer, breaks down data into segments to transfer from one application to another. Segmented data to not exceed maximum frame size or maximum transmission unit, MTU, provides services such as reliability, flow control, and multiplexing, uses TCP connection-oriented and UDP connectionless, forms data packets adding source and destination port addresses in the header of each packet, ensures reliable delivery to the destination location. Layer 3, network layer. The network layer handles logical addressing, translates logical network addresses into a physical address, and performs best path selection and routing in an internetwork. It is also the traffic cop for network activity because it provides access control. The software components working at this layer includes IP, ARP, and ICMP from the TCP/IP protocol. A layer 3 switch also works on the network layer.
Layer 2, the data link layer. This layer defines how computers access the network medium. It's also known as media access control or the MAC address. It recalculates the cyclic redundancy check value, or CRC. It is recalculated at every intermediary device. This layer also contains fields for source and destination addresses. This layer strips the frame of its header and trailer information, and the resulting packet goes to the network layer. Software and hardware include NIC drivers and the NICs and switches themselves. Other protocols include Ethernet, Token Ring, and FDDI. Layer 1, the physical layer. This layer is responsible for converting bits into signals for outgoing messages, and it also converts signals into bits for incoming messages. The types of signals depend on the network medium. This layer also specifies the details for creating a physical network connection. This also specifies how to encode ones and zeros. Encoding is defined as representing zeros and ones by a physical signal. The hardware included are cables, connectors, repeaters, and hubs.